Lesson 2, Aluminum, Aluminum Alloys, and Magnesium. Please turn to page 25. This chart shows the 19 and 21 series of alloys for joining aluminum. On the left are the torch alloys. On the right are the arc electrodes. The large circles are the primary alloys, one for torch and its arc equivalent. 90% of the time you will use these primary alloys for all aluminum joining operations. The special purpose alloys are for specific problems. The secondary alloys have been developed to solve these problems. Many operators regard aluminum as a difficult metal. It does not show heat color. It has a high affinity for oxygen, and oxides form almost as rapidly as they are removed. Rod 21 FC is used for most joining operations on sheet aluminum, castings, alloyed castings, and aluminum die casts. It is applied nearly 200 degrees Fahrenheit below the melting point of aluminum. Heat the tip of the rod and melt a little flux onto the joint area. This is your temperature guide. When the flux melts, it is your signal to apply the alloy. Aluminum oxide is difficult to remove, but if you apply the rod with a scratching motion, you will expose clean metal. Deposits will alloy readily with a chemically clean surface. If aluminum parts have been formed in a die, the metal will usually contain zinc, tin, magnesium, and sometimes lead. The zinc has a low vaporization point, but if the low heat input method is used, the zinc will not be burned out of the metal. Use Eutector Flux 21X on aluminum die cast with Rod 21. Always heat the metal in the vicinity of the joint area. Never heat the flux directly. When the heat of the metal melts the flux, it is a true indication that the joint area has reached its approximate bonding temperature. The bonding temperature differs with practically every metal. This is why every flux is designed for a particular alloy, and every alloy for a particular metal. Test the joint completed with the low heat input process, and it will break at a point a few inches away from the joint area. Figure 26. This proves that the aluminum has retained its strength even in that vulnerable section adjacent to the joint area. Figure 27 shows how a fusion welded joint breaks directly alongside the weld area, which proves that the base metal was weakened. When a bead-forming alloy is required with a similar coefficient of expansion to the base metal, together with high corrosion resistance, Rod 210 FC is available. When the melted flux gives the signal, apply a bead to the beginning of the joint area. Keep the torch in motion across the base metal and the drop of filler metal until the bead alloys to both sides of the V and forms a concave fillet. Apply another bead and flow it ahead until it alloys to both sides of the V. Each bead should alloy with the base metal before another bead is applied. This will give you strong, dense deposits. No dilution will occur to cause porosity. When heavy sections of aluminum are joined to thin sections, apply flux to both pieces. Concentrate the heat on the heavy section about 1 inch from the joint area. When the flux liquefies, heat the thin section lightly until the flux is fluid. Deposit a bead and heat across the bead until it alloys to both sections. When each bead is flowed ahead before depositing more alloy, there will be no flux entrapment to cause porosity in the deposits. Zigzag the flame of the torch across wide V's to distribute the heat evenly to both sides of the V. When a thin flowing alloy is needed, use Rod 190 with 190 flux. It will join sheet aluminum, angles, and pipes. Use it for butt, lap, T, and corner joints. All thin-flowing alloys are used with a similar technique. Apply the flux and heat the part broadly until the flux melts. Apply the alloy. Keep the torch in motion to maintain the correct heat throughout the joint area. When the alloy appears upon the opposite side, the joint is completed. Many operations call for aluminum alloys with melting points in the solder heat range. Rod 19 will bond at approximately 450 degrees Fahrenheit. It requires no flux and is almost as tough as aluminum itself. It is used in foundries for building up worn aluminum patterns, for filling in porosity and cracks in aluminum heads, blocks, and water jackets. Riveted joints or Pittsburgh seams are sealed with Rod 19. Aluminum is often joined to steel, copper, nickel, Monel, brass, and bronze. Sealing and filling operations upon these combinations of metals should be done with Rod 199 and 199 flux. It is a solder-type alloy which flows well through lap joints. Alutin 51 is a solder-type alloy with the flux contained in the core of the wire. Although designed primarily for aluminum, its superior wetting action makes it ideal for joining other metals which are difficult to join with conventional solders. Ordinary rosin or acid core solders do not wet aluminum readily and give a purely mechanical bond. Alutin 51 fills the need of the operator who wants one solder for a large variety of jobs. Powder eutector fluxes are more active in their dry state. Do not expose to moisture or humidity. When production operations call for a paste flux, mix the flux with water to a creamy paste. Prepare sufficient for 1 day only, because the paste loses its strength rapidly after the first day. Do not use fluxes as degreasing agents. Oil neutralizes the action of the flux. Aluminum is usually protected by a thin film of fish oil. Immerse the part in aluminum pre-cleaner, Eutectic 1002 pre- and post-cleaner, and all grease and oxides will be removed from the surface. The flux has to be very active, and if permitted to remain on the aluminum, it becomes active again whenever moisture or humidity is encountered. The white powder seen on the surface of an old weld is corrosion. The still active flux is dissolving the oxide and eating into the metal. Dip the finished parts into a hot solution of the aluminum pre- and post-cleaning solution. The high heat conductivity of aluminum always presents a problem. An iron bar can be held in the hand without discomfort while its tip is heated to redness. An aluminum bar would have to be dropped long before the same amount of heat had been applied to the tip. Unless the heat is restricted to the joint area, the whole part will have to be brought to a bonding temperature. Pack forma-jig around the joints of small parts. This prevents heat dissipation and confines the heat to the joint area. When an aluminum part is positioned in a steel jig, the part must be insulated from the steel. Place pieces of transite or asbestos between the part and the jig. Without insulation, the steel will conduct the heat away, and a bonding temperature will not be reached until the jig is at the same temperature as the aluminum. The part must be free to expand and contract in the jig. If held rigid, stress will be set up and cracks develop. When large parts are involved, use the electric arc. Heating is rapid and confined to a relatively narrow area. This is why torch alloys have arc equivalents. Eutectrode 2100 is the arc equivalent of 210 FC. It is a primary electrode for heavy aluminum plate, cast aluminum, and extrusions. The special coating permits it to operate as an arc electrode or with the oxyacetylene torch. When thin sections are involved, apply the alloy with a torch. For heavy sections, use it as an electrode. If an alloy is required for torch applications on cast and sheet aluminum and as an occasional arc electrode, 2100 is the answer. For arc welding alone, there is nothing to surpass Eutectrode 2101. It is more stable. An arc can be struck more easily. It is easier to maintain an arc, and it is very easy to apply. It operates at an extremely low amperage and this reduces the heat input to a minimum. The amount of heat transferred to the base metal, or the heat input, is the important factor in all joining operations. Careful alloying achieves this with the torch alloys and low amperage with the electrode. The food and chemical industries need a pure aluminum electrode for fabricating and repair. Kettles, agitators, and containers which are in contact with food or exposed to the action of chemicals must be welded with pure aluminum. Use Eutectrode 2102 for such operations. The weld deposit can be anodized, and the corrosion resistance will equal that of the base metal. Magnesium closely resembles aluminum in appearance. When in doubt, cut a small section from the weld area and melt it. Magnesium will burn with a brilliant white flame, and aluminum will remain a molten globule of metal. Operators hesitate to work upon metal which might burst into flame, but this danger is reduced if Eutectrode 1902 is used with 1902 flux. The flux is a safeguard against overheating, and the alloy is applied below the melting point of magnesium. Eutectrode 1902 is bead forming at lowest application heat and thin flowing when the heat is increased. Use it for sheet and cast magnesium, tubular sections, and aircraft parts. Hold the torch at a low angle at all times. Pre-cleaning improves flow characteristics, and deposits can be applied at a lower heat. Post-cleaning is important. It reduces the danger of flux corrosion.